This video is about process management and is produced by the following students.
The definitions of the process management. Process management involves performing various tasks such as creating processes, scheduling processes, managing backlog, and terminating processes. The operating system is responsible for managing all running process of the system. The operating system manages process by performing tasks such as resource allocations and process scheduling. The operating systems must also synchronize the different processes of the computer system. A process consists of a set of instructions to be executed. It is called a process code. The process is related to some of the data to be processed. The resources required for process executions are called process components. There are also steps associated with processes called specific moments of the process stage. Even in multitasking, the computer systems can execute as many program instructions as there are processors at any given time.
How process management works? So, how does process management actually works? Before that, we will have to understand the meaning of process. A process is a program in execution or running program that has been loaded into memory. A process may have a few threads or just one thread. A thread is a sub-process that executes independently of the parent process. While a process is executing, it has complete control of the processor, but at some point, the operating system needs to regain control, such as when it must assign the processor to the next process. Execution of a particular process will be suspended if that process requires an I/O operation or an interrupt occurs. When a user starts an application program, the operating system scheduler loads the program code from secondary storage into memory. It then creates a data structure in memory called a process control block, or known as PCB. They will be used to hold information about the process, such as its current status and where in memory it is located. The operating system also maintains a separate process table in memory that lists all the user processes currently loaded. When a new process is created, it is given a unique process identification number, or known as PID, and a new record is created for it in the process table, which includes the address of the process control block in memory. The operating system must also allocate resources such as access to I/O devices to process if the process requires them. Information about the resources allocated to a process is also held within the process control block. The scheduler is also responsible for allocating CPU time to each process in turn.
Responsibilities of process management. For the first one, I would say that process management can maximize the CPU utilization by doing multi-programming, which means instead of running one process, the operating system will run the other processes at all times to make sure the resources are being allocated and maximize the system performance. For an example, when user is doing assignment using Microsoft Word and listening to music at the same time. Also, in process management, it is responsible for process termination, which is to stop an execution of a process when it reaches the final statement or facing interruption. When the process is terminated and deleted, the resource used by the previous process will be deallocated in order to be used by other process to ensure the resource will be sufficient for the other processes. Lastly, one of the responsibilities of process management also includes prevention of deadlock. What is deadlock? It is a situation when two or more processes get blocked and cannot proceed further with their processing because of the interdependency. Process management included deadlock prevention and also deadlock avoidance. For deadlock prevention, there are 4 conditions for deadlock to occur if 4 of them happens together. Deadlock prevention is to make either one of them come forth so that deadlock will not happen. For deadlock avoidance, it checks the state of a process whenever the process requests for a resource. If the state is safe, it means no deadlock will happen and vice versa.
Example of process management. For example, Linux process state can be in a different number of different states. The most common states are, first of all, the running state. It is just waiting for the CPU process. After that, if waiting for any event to complete, the interruptible sleep state will wake up or active, such as any input from the terminal. Then, what if any process that can't be queued or interrupted? The uninterruptible state will send a signal or active and will go through the running state again. What if it doesn't need any of the event, I/O or interrupt process? Then running state will send a signal to the stop states and the process will be suspended or stopped. At last, if the process isn't having any process again in current processing, then the running state will exit the process to the zombie state, which means that terminated process they are waiting to have their status collected.
Conclusion. In conclusion, the basic of process management are the capability of sharing and exchanging information with processes, maintaining the resources of every process by protecting and allocate the resources to the process, and last but not least, the power to run processes at the same time. Process management is an essential element within the operating system of these days, with great responsibilities to manage every processes of the system that are running. It is very important in this era because operating system now will have to face multiple programs at once more. To be able to use 100% of the resources, it is the task for process management to do for the outcome of having efficiency by running processes.